はじめまして。私はNingです。DOBOTから。どうぞよろしく。I'm very honored to give my presentation here, and I'm a little nervous standing in front of so many important guests. If I made some mistake, please forgive me. Thank you very much. Okay. This speech has 3 parts. It's robot, technology, and roadmap. Where robot comes? We know that development of the industry, from mechanized production, mass production, and to automatic production. Now, we are in Industry 4.0, and digitalization, networking, information, and AI technology bring us to the new industry century. And the robot is the kernel part of the Industry 4.0 of the smart manufacturing. Robot is a comprehensive engineering technology. It contains mechanical, electrical, and computer science, and others. Robots can do a lot of work for human beings, especially in 3D industry, like dangerous. It's for high temperature, radiation, and this environment is harmful to our body, and dirty, it's with dusty and smelly, and dummy, the work is heavy, repeat, and meaningless. This work should be done by robot instead of human. So, how does it free our hands? Like action, pick up something and move to a target position, then drop down. How to achieve? How can you, by using some electrical components and metal structure to realize that? Yeah, it must like human beings have a structure like us with bone, muscle, and brain. Yeah. At first, the robot must have a body that's described by the Dennevit-Hartenberg notation. In this notation, we can get the information of the robot, how long is the rods, and how rods join together. Computer will know the information of the body, and they can calculate. Okay. After the robot has the bone, it must have muscle to supply some dynamic. Okay, usually, the dynamic is about the step motor and servo motors and AC motors. Drivers receive the signal from the controller and calculate the current to the motor to rotate to the target position. And the performance of the movement relies to the design of the driver loops. Okay. In the end, robot system must have a brain. It's composed with hardware and software. Hardware gets the feedback, like encoder and so on, from the body, and calculates the position we want. Okay. Because the brain of the robot knows the structure of the body, she can calculate where the motor should rotate to, and planning the path. Okay, what are we doing? DOBOT has developed our controller and driver and robot arm that makes Magician and M1. Is there something different with the normal industrial arm? Yes, there must be something new. For example, we can give the command via speech from my voice instead of pressing button. It's something new, interesting. And for M1, it will, if it knocks at someone, it will feel the resistance and it will stop at once to help to protect human from the second damager. Okay, I will show something we are researching. Difference between DOBOT and the normal industrial arms is intelligence, means intelligent sensor. Yeah, we want the robot to have eye, have ear, and knowing the path. With vision system, robot will find the target and know the obstacle. It can just pick the object and avoid the obstacle. For example, like here, okay, it can avoid the obstacle. Okay, after it has air, robot system may know our command. If I say, go to the door and get my newspaper, okay, the robot will get the keywords, door and paper. It will find a way to the door and looking for where newspaper is and pick it up. Okay, this is why we want robots have ear and path. We know that usually we control robot by demonstrator. Yeah, you know, blah, blah, blah. Now, with DOBOT arm, you can draw it. Yeah, you can just pull it to anywhere, and it will remember where it went. Then you send a command that to replay the path, and the robot will redo it. That makes the usage of the robot arm easier. You don't need to study how to use a demonstrator. Yeah, these are difference. And dynamic. This may be the difference. We can get the current value from the driver, and we will check abrupt change. That means the robot knocked at something or human beings. The robot will stop at once to avoid damage again. Then, furthermore, the robot can calculate the friction force and adapt the load automatically. Yeah, you can draw it easily. After that, the computation period is about 100 microseconds, and it can estimate the external force. That's helpful to, It's helpful to improve the experience of drawing teaching. You can set the point by drawing it, not use the demonstrator to up and down and remember the point.
今のところまでなんですけれども、DOBOT 社は小型のロボットアームをベースにですね、ソリューションを提供しておりまして、特にインダストリー 4.0 の潮流の中でですね、非常に簡単に使っていただけるようなロボットアームのソリューションをご紹介しております。体にちょっと見立ててですね、ボディの部分とか筋肉の部分とかっていうところがどういうものかっていうのをご説明させていただきました。で、今ご覧いただいているダイナミックの部分っていうのはこれからちょっと新しくご紹介するようなところになってくるんですけども、ビデオではスカラ型のロボットアームご紹介してますけれども、人間の手でダイレクトティーチするっていうところはご存知の方結構いらっしゃるかと思いますけれども、さらにこれからファームウェアがアップデートされてもうちょっと機能がアップしてきます。またちょっとお話があるかもしれません。すいません。
Okay, there is another difference. It's the open architecture with DOBOT and normal ARM. Yeah, everyone knows that usually we teach robot by teaching box. Yeah, you have to use it. And if you want to develop something where this platform, what can I do? Nothing. They can't receive command from your applications. But we support many API for this platform, like LabVIEW, MATLAB, Robot Operation System, Arduino, Python, Java. So you can develop some interesting applications for play trace and so on. You can call the API directly and to control the robot arm of DOBOT is different with normal industrial arm. Yeah. Okay, roadmap. Now, DOBOT magician are most used for education as a bridge to robot kids and between the real robot application. Customers can use it to learn the series of robots, such as computer science, structure, mathematics, program, driver, and so on. They can learn the series of the robotic. Okay, so we developed a series of products like printing and wheel kit, conveyor belt, linear wheel, Arduino kit, and mobile platform. This will be helpful to learn and use the robotic. Oh, sorry. This is a little demo.
これもアプリケーションの一つで、Arduino というシングルボードコンピューターでロボットアームをコントロールするというようなものですね。それからロボットアームの先端のエフェクターは自由に作ることができるんですが、このデモではカメラを使って物体を認識しております。今ちょっと声が出てきたのは音声認識ですね。こちらのプラットフォームをインターネット経由でつなげて、物体の色を指定しているという形です。
Yeah, you can control the robot arm like playing PlayStation. Yeah. It's very interesting for learning program. Yeah. In the research field, we have three directions. There are AI intelligence and industrial arm and co-robot. First is AI. Yeah. This picture is cut from our software. It shows the point cloud of bottles mixed in a box. And we developed a research to find the 3D target. Then the robot will calculate the path automatically to catch the target from this way or this way to find the plate surface to pick up it. Okay, after that, we embedded the vision system. So now you can connect the camera to the controller directly. And the robot system will execute the digital image processing. You don't need another PC as usual. You can connect the camera directly to the robotic system. Yeah, you saved a computer. Okay, and we supply some API for Python. We know that some AI is based on Python dialogue. So there is much interesting usage on this platform. Like ASR, like words analyze. Go and get my newspaper. It will separate the keywords. That's what ASR doing. Yeah, it's very interesting. Okay, this picture shows an AI lab built in London using DOBOT magician. Yeah, it's researching, processing, emotion research, and computer vision. The professor said DOBOT is an opportunity to explore multiple technologies. It's in Oxford, yeah. Above is about AI, and now industrial arm. We are planning to improve our Magician Plus. We will use a motor with closed loop and high precision position sensor and more stability coupling. The purpose is improve the precision and more stability. For software, we will make it most easier to operate, like program offline operation and I/O with PLC. Yeah. Next, Scala arm, but use DC servo motor, and the motor and driver is integration in the rods, and the controller is here. You don't need anymore the electrical box so big. Don't need that anymore. All in one, just this. Straight off, 3-degree of freedom arm. What we have done is only reduce the count of AC driver. You know, the driver means the cost. Several motor was served by one driver, so we can reduce the cost. And after that, collaborative robot. Okay, this one is a new thing. Like M1, it uses DC motor. Could work together with human. Supporting drag teaching. Yeah, you can drag it here, remember, and next point. Yeah, you don't need to use the teaching box. Okay, and it uses DC driver, so it can be installed on AGV. Okay, what AGV? This one, newcomer. It was developed by ROS platform and laser radar inside, with SLAM and navigation inside. Its battery could supply 48 volts DC, so it can support robot arm. Let's see a little video. It can explore the unknown environment to build a map automatically. Yeah, it's building map. It will know where is the wall, where is the obstacle. Yeah, it's a map. This is a robot. Now the map is okay. You can send a command like this. This is the path planning. And it's real-time obstacle avoidance. You can stand here and put something in front of it. It will avoid it, and planning another way. This is a real-time map. And we added an ear in it, so it can recognize the voice. He said 10 left. He said stop. And turn right. And goes back. now it can help to transport something, and you don't need a belt or a rail. Yes, the robot arm has a leg. Okay, these are advantage of DOBOT lightweight robot. Sorry.
今、ロードマップのところざっとご紹介させていただきまして、フォーカスをしていくポイントを3つ挙げさせていただきました。AI とインダストリーロボットと、協調ロボットですね。で AI の方は、アプリケーション寄りではありますけれども、Python コードを自由に使えて、でカメラシステムと連動してピックアンドプレイスをしていく。そして、音声認識あるいは、自然言語に解釈ですね、そういったものもアプリケーションの中に入れて使いやすい環境を整えていくというようなところが一つのポイントになります。でもう一つが、産業用ロボットで、現在DOBOTマジシャンと M1 というものを提供させていただいておりますけれども、さらに工場内の主に軽作業ですけれども使っていただけるような新しい新製品を準備中であります。で特徴的なところはやはりコストが非常に安価なものをターゲットにしておりまして、コントローラーもですね非常にシンプルにエンベデッドされたような状態でご提供する予定でおります。で協調ロボットというところが3つ目の柱になっておりまして、特にビデオの方では AGV ですね、非常に日本のお客様もこういうものないのかっていうようなご質問いただいてるんですけども、ようやく出てくる予定ですので、もう少々お待ちいただければと思っております。はい、
These are advantage, like low cost, easier installation, collaborative, and high precise, and especially safety. It will stop at once if it knocks at something. Magician is widely used in university education globally, such as University of Technology Sydney. It was used to teaching robotics and forward and reward kinematic. These are some other education institutions. These are interesting commercial application. This one, robot is dancing with human in a drummer. And it can make ice cream, coffee, and so on. This is some business applications. Make a cake, make a cocktail, and sorting chocolate. Even play chess with you. These are more applications. Yes, more innovation are waiting for you. Okay, that's all. ありがとうございます。
最後にちょっとまとめさせていただきますと、DOBOTマジシャン M1 だけではなくて、これから新製品出てきますけれども、教育の部分というところも一つの大きな柱で、午後のセッションは主に教育の方をやらせていただいておりまして、徐々に日本のお客様にもですね、学校であったりとか、研究機関の方にですね、講習会トレーニングの方を提供させていただいております。でさらにインダストリーの方も力を入れておりまして、基本的には同じプラットフォームで簡単にそして安く使っていただけるようなロボットアームのソリューションを提供していきます。はい、ありがとうございます。